Hello everybody, this is Rudra Pradhan here. Welcome you all to BMD lecture series. And today we will continue predictive analytics 1 and that too discussion on multiple regression modeling. In the last couple of lectures we have discussed this particular concept, and that too to highlight how to predict a particular variables as per the business requirement, and then how to take a kind of management decisions. And the discussion which you have earlier is with respect to two variables, and that too one is a dependent variable which need to be predicted, and then that is with respect to a particular independent variable. However, in a kind of business environment or in a real life scenario, so the prediction of a particular variable reflected by various various factors which we have already discussed in the last lectures, like the key performance of kind of in a particular organization. Now, when we are interested to predict a kind of variables, then we have to first identify what are the factors through which you can do the kind of predictions. So, there is a high chance that the prediction of that particular variable will be reflected by more number of variables, and in a kind of real life scenario or the kind of dynamics kind of environment. So, if you like to predict a particular variable with respect to multiple independent variables, then the accuracy or the kind of the kind of optimality will be very perfect, and that is why we have to very careful how to address the kind of predictions, that to the predictive analytics, that to with the help of more number of independent variables. So, the prediction of a particular variable with respect to one independent variable is very easy to handle or easy to address, but when we will be dealing the same problem, means the prediction of that particular variable with respect to more number of variables, then there are lots of complexity you will find. So, now how will we address all these complexity and we will be dealing with all these problems. So, today we will discuss on that aspects, and there is a high chance that the prediction of a particular variables with respect to more number of independent variables will give you better kind of management decisions, or as per the particular business requirement. So, with this simple kind of background, so we will start the kind of discussion, and the literary framework of multiple regression model is like this, and where y is the dependent variables, and then x1, x2, x3, x4 up to xk are independent variables. So, that means technically, so in the first instance the regression modeling can be divided into two parts, and the simple regression modeling and then multiple regression modeling. So, we have a concept called as a multivariate regression modeling, which we are not discussing right now. So, the today's discussion is with respect to multiple regression modeling. In this case, so here the kind of there is a issue of n and there is a issue of k corresponding to the earlier discussion. This is also the game of n and k. So, here in the simple regression modeling, k is equal to actually 2, that is the number of variables, and the n is the sample size, and the requirement is n should be greater than 2k, and out of this total number of variables, one will be dependent variables and the other one is the independent variables. And in the case of multiple regression modeling, so obviously the same rule will be applied, n substantially greater than 2k. However, in the case of k, so the cluster will be so one dependent variables, and then more number of independent variables, right. So, this is how the typical structures which we like to follow. So, now, so how many independent variables will be there in a particular system, or that exclusively depends upon the kind of business environment or the kind of business problems. So, we have actually also the kind of structures where we can actually include one after another variables, and then we can also exclude one after another variable depending upon the particular requirement or the kind of management requirement. So, in the case of in this particular case, so we have to see how best we can actually address the problems, and then we will do the predictions with with respect, means prediction of y with respect to the several independent variables. So, now that means technically how many variables will be there in the systems, the number of independent variables that to predict the variable y. So, that exclusively depends upon the kind of theoretical background about the business problem, and from the theory you have to just identify the independent number of independent variable which can actually reflect the dependent variables. So, it should not be actually the kind of arbitrary choice. So, it is exclusively depends upon the theoretical background behind this prediction, and then we will try to incorporate all these independent variables. And when we are incorporating all these independent variables, so that times, so we have to see actually, so how best we have to fix all these variables subject to the validity and the reliability is concerned, right. So, let us see how is the kind of structures, and in the first instance, so the regression framework will be written like this, and if you put in a kind of in a summation form, then this will be the regression modeling will be y equal to simply beta 0 plus summations beta I x I equal to 1 to n and then the error term. So, this is how the general format of multiple regression modeling. So, now when you put I equal to 1, and then the model will be restricted to this much. When we put I equal to 2, then the model will be extended to this much. When we put I equal to 3, then this model will extend to this much, like this. So, this is a kind of continuous process, and yes, mathematically it is very easy to include one after another variables, but we are not dealing with mathematical problems. We are dealing with the business problem, and we will include the variables which are actually relevant for this kind of for the prediction of that particular variable. And corresponding to earlier discussions, so the beta 0, beta 1, beta 2, beta 3 are the kind of parameters, and these are all called as a partial regression coefficient of independent variables from starting from 1 to k, and beta 0 is the regression constant, that is actually intercept term, and then there is a kind of error terms. So, obviously, in fact, obviously we should like to know, so why there is intercept and why there is a kind of error involvement in the particular process, because the first instance is you are predicting y, then without the kind of independent variables, the y can also be there in the system. For instance, let us take a take an example of consumption predictions with respect to incomes. So, now consumption typically depends upon the income of a particular persons, but you will find in a real life scenario lots of people are there, they have no income, but by the way they must have actually consumption. So, in that case, so when there is no income, still there is a consumption, and that consumption will take care by the intercept. Okay. So, that means, so the consumption of a particular individual will not depend upon his or her income, but it will be it will be depend on somebody's income or something like that, right. So, that is how, so the intercept will be there in the system, and in the meantime, so error term why error term in the system of regression modeling, because of many reasons, and one of the typical reasons is that we are not in a position to capture all the independent variables to predict the dependent variables. Since we are not in a position to incorporate all the independent variables, so the error term can take care that particular missing variables. And sometimes when you are means we are dealing with the data, sometimes there may be error error in data entry or something like choice of the particular functionality and choice of a particular model. So, like that there are many different regions through which we have to incorporate the error term in the systems, and in fact we have already discussed this particular aspect, and typically the regression framework is dependent variables, independent variables, and the parameters. Out of all these parameters, one is the independent with the all independent variables, that is what intercept, and the other variables are reflected by the coefficients like beta 1, beta 2, beta 3, and then the error terms. So, this is the framework of multiple regression modeling. And now, how will it deal with this models to predict the business environment, or to do the kind of management problems kind of investigations. So, we will get to know in details. So, now the kind of structure will be like this. So, corresponding to the previous model. So, this is what the estimated model. So, that means, we have a structure of population model, then this is the sample specification, and here. So, with a particular samples or the kind of structure. So, we have to estimate the models, and the way we will estimate the model, the error terms will be removed in the process. So, that means, technically we will first build the model like the previous ones, and then here actually there will be error terms, and then these parameters are unknown. Now, with the sample data or the sample problem, so we have to estimate the particular models, and then by default error term will be removed, and finally, the coefficient will be there to predict the kind of dependent variables. So, that is the usual structure, and which we have already discussed in the last lectures. And so, for the simplicity point of view, so let us start with two independent variables, because we have discussed the kind of regression modeling with respect to one independent variable in the previous lecture, and here we will just extend by putting one more independent variable in the system, and we will see how is the particular structure. Then by default we can actually extend the particular process of the variables, then slowly you can actually drop if it is not actually coming important for this prediction. So, we get to know in details in the later stage, but in the meantime. So, this is how the particular structure, and in this structure. So, this is the kind of population model, and this is what the sample specific model, and where error term will be not there in the systems, because it will take care with this data or the sample problem. So, now corresponding to this. So, we will see how is the particular structure. So, typically the kind of requirement is like this. So, when you have actually dealing with the two independent variables, typically. So, that means, this is what the y variables, and this will be reflected by two independent variables, that is actually x 1s and then x 2. So, that means, this is how the game all about. And since we are dealing with two independent variables, so there should not be any relationship between x 1 and x 2. So, if there is a again relationship between x 1 and x 2 while predicting y, so this will be again problem. So, which that problem we will discuss in the later stage, but in the meantime. So, you can now fix the model like this, y equal to function of x 1 x 2, and then the regression modeling will be y equal to beta 0 plus beta 1 x 1s plus beta 2 x 2, and then plus error terms. So, this is how the simple mathematical representation of the prediction of y subject to the availability of x 1 and x 2. So, now we like to see how is the kind of estimation process. So, ultimately the idea is we have to apply Wallace technique, and then we try to minimize the error sum squares, and the way we will minimize the error sum squares, then the coefficients by default will be calculated. And in the last lectures we have dealing with two variables. That means, in that case it is a least square estimation for k equal to 2, that means two independent variables. So, now in the earlier case we have discussed with one independent variable. So, that is why we dealt with the two different structural equations. Now, since there are three parameters and three variables y, x 1 and x 2. So, you must have actually three structural equations. So, these are the equation through which actually you have to address the kind of problem, and then after simplifications you will get the values of these parameters. So, typically, so you have actually y, x 1 and x 2. So, now, so you need actually summation x 1, summation x 2, then summation y. So, that means, the with respect to the data. So, you can find out this summation, then you need summation x1 square and summation x1 x2 and summation x1 y. Then finally, you need summation x2 square and summation x2 y. So, after go to the Excel spreadsheet and manually you can calculate all these things. After getting all these value, you can just put here and then solve these equations, and then by default you will get the coefficients of b0, b1, b2. These are all the parameters through which we need to actually do the predictions that is with respect to y. And so, corresponding to these equations, so we can connect with a problem and then get to know how this actually the process is happening. So, here let us take an example. So, this is a real estate problem, and in the real estate problem, so every time our job is to predict the housing price. So, that is the market price of a house, and it is reflected by two independent variables, that is the size of the house, and that is measured with respect to square feet, and then age, number of years, depending upon the kind of building construction. So, this is the this can be the another variable through which you can do the predictions. So, that means technically, so we have actually dependent variable here, and then two independent variable x1 and x2 and 12 and 23. So, total 23 sample observations, and since so that means n equal to 23 here and k equal to 2, that is two independent variables. That means some total variables here is 3, and as a result, so n is greater than 2k. So, accordingly we can actually do the processing, and that means technically this is fair enough to proceed for regression modeling and do the prediction, and then come to the kind of management decision. So, now the way yesterday we have discussed, so we can proceed for these calculations, and then same things. So, after the estimations you will get this y estimate, and the parameters, now this is actually b0 and this is b1 and this is b2. Okay. So, that means initially we are assuming that so high the square feet, then high is the housing price, and the number of years means it depends upon the starting of the construction. So, when the building will be older and older and older, then the value of that particular price will be negatively connected. So, as a result the coefficient is also coming negative. So, that means before you start the process, you must have actually theoretical expectation what should be the kind of link, and that need to be validated through this data set or the kind of samples. So, now our job is actually to predict the market price of the of a particular house, and here there are two variables, and having a x1 the kind of fix of the square feet and the kind of number of years of that building. So, you can actually predict what should be the housing price. So, now putting x1 equal to 2500 and x2 equal to 12. So, you can say that the housing price for this particular x1 2500 and x2 12 will be $93.66 $1000. So, this much actually you have to predict. So, that means just you imagine how regression can useful for doing the predictions, and that too how predictive analytics can be very useful for doing the kind of management decision. So, now only thing is to know how these parameters are coming, and in fact, we have already discussed the particular process how to get all these parameters. So, once you get these parameters, then by default you can do the kind of prediction. So, we can go to the Excel sheet, and this in the spreadsheet very easily you can get these output, and just you need to connect with dependent variable and independent variable, and by default you will get these results. So, after getting these results, so you have to just check that whether these coefficients are statistically significant and the goodness fit of this particular model. So, that which we have already discussed in the previous lecture, and that is same thing here. That was with respect to 2 variable case. Now, it is with respect to 3 variable case, where one dependent variable with the 2 independent variables. So, now knowing the output, so we can proceed to see how is the kind of testing. So, this is what simple prediction. Now, in this case, So, the coefficients are actually beta 1, beta 2, beta 3. So, that need to be equal to 0. So, the alternative hypothesis will be they are not equal to 0. So, as a result, so we like to check what is the sample estimates, and then on the basis of sample estimates, and we have to check, apply the t statistic and then check the significance of these parameters. So, that means in this case we have actually two parameters, that is beta 1 and beta 2. Beta 1 is reflected by x 1 and beta 2 is reflected by x 2. So, that means we like to know which particular variable is significant and which particular variable is not significant. Means we need actually both variables should be statistically significant, and then we like to check whether both are statistically significant or they are not at all significant, or at least one is significant to predict the y, that to housing price with respect to number of years and the kind of square feet, right. So, this is how the process, and then we will check how is the kind of testing. So, the testing followed by two-way structure. First check is the overall fitness of the model. So, that is the ANOVA, which we have already discussed in the last lectures. So, the ANOVA statistic depends upon three things: TSS, ESS and RSS, and it will be reflected by two major indicators, that is R square, the coefficient of determination, and which is the ratio between ESS by TSS, and then F, which is reflected by R square by 1 minus R square, and subject to degree of freedom and subject to degree of freedom, which we have already calculated here. So, this is actually F calculation, and this is the R square value will be just with the help of explained sum square by total sum square, it will get R square value. And like the previous discussion, higher the R square better is the model fit, lower the R square lower is the model fit, whether it is a higher and lower. So, we need actually the significance of overall fitness of the model, that is reflected by F statistics, and again we have to follow the particular structure of alpha fixation and the kind of degree of freedom. Then you have to find out the critical value. So, in this case we are putting actually alpha equal to 1%, and then the number of sample points corresponding to the number of sample points. So, we are getting the critical value is 5.85, that is actually because in the F statistic we need 2 degree of freedom, the upper part and the lower part. That means technically for this side and for this side. So, this is reflected by 2 and 20, and then so this is the calculated F statistics. So, now we have to compare, since the calculated value is overtaking the critical. So, we can actually reject. So, that means so the model is saying that the fitness of the model or goodness of the fit is actually fair enough to go for the kind of prediction. So, the other check which we will need to have, so that is actually with respect to the parameters, and we should know that the beta 1 beta 2 should be actually statistically significant or not. So, accordingly the null hypothesis will be, so beta 1 equal to 0 and beta 2 equal to 0, and the counterpart alternative hypothesis will be beta 1 not equal to 0 and beta 2 not equal to 0. It is also same thing. So, these are all beta coefficients. So, this is actually beta 1 coefficient and this is beta 2 coefficient. So, the intercept which we are actually skipping here, because it is not important when we will go for more and more variables to predict the y. So, the variable importance more important than the kind of intercept, but when you are having less and less number of independent variables, then the intercept impact may be coming high. So, now accordingly so you can actually calculate the kind of structure, and then you check whether it is coming actually statistically significant or not. So, now the same structure. So, you have to compare the calculated with the critical, and the calculated will be coefficient with the standard error, and then you will get the t statistics which is calculated for x 1 and that is beta 1, and this is for beta 2 and that will be with respect to x 2, and then critical value is 2.086. So, in both the cases they are crossing the critical level. So, that means the calculated statistic is overtaking the critical value. As a result, we are in a position to reject the null hypothesis. So, technically, so we are in a position to predict the y now with respect to x 1 and x 2. So, that means the problem which we have connected now to predict the housing price, market price of house subject to the size of the house and the number of years, the kind of with respect to their building. We have to predict the kind of situation, and then we have to take the kind of management decision. What should be the future market price of that particular house subject to the square feet and the kind of number of years, that is the age of the house. So, now so likewise it can be also actually extend with respect to more number of variable here. So, the same structure. So, we will once you get the estimated model. So, we will be dealing with residuals. So, first thing you have to find out the residuals. So, which is actually the difference between y minus y head, and then we have to see that the sum of the estimated error sum should be equal to 0. So, that means technically this error sum should be equal to 0, and a sum of the error square is nothing but actually squaring all the items, and then you take the summation, that is actually sum of the error sum of the squares. And then once you get the error sum of squares, so with the help of this error sum squares, so you can actually do the entire testings, that is the kind of goodness fit check and the kind of specification check, that is with respect to the parameters beta 1 and beta 2. Okay. In means particularly with respect to this problem. So, now this is how the particular structure, and we have already discussed. So, this is what actually the calculated f value, and it is actually statistically significant, right. Now, so the R square value is coming here in this particular structure, that is the ratio between ESS to TSS. So, that is coming actually 0.741, and that means technically so it is actually coming 70%, what we will call 74%. So, the impact of independent variable to dependent variable is reflected by 74%. So, that means it has a high accuracy to predict the kind of housing price with respect to the size of the house and the kind of age of the house. So, this is actually very interesting to know the kind of structure, and then you have to take the management decision as per the particular requirement. And knowing all these things, so it is easy to check the kind of process, and then we will see how is the particular structure. So, R square will be again there is a kind of adjusted R square, and since when we go for more and more independent variable, then R square will start increasing indefinitely. So, as a result, so when we are dealing with multiple regression or multivariate regression, that time it is the adjusted R square which can reflect the kind of predictions rather than simple R square. So, usually adjusted R square can be written as this is adjusted R square, this is nothing but 1 minus R square into n minus 1 by n minus k, that is the degree of freedom, and simply you can calculate it by this particular process. And if the sample size is very strong enough, then the difference between R square and adjusted R square will not be higher, but if it is in the case of small samples, so there will be a difference, and that may affect the kind of predictions. But by the way, so whether it is R square or adjusted R square, both are good the kind of indicator through which you will do the predictions, and that to predict the housing price with respect to size of the house and the age of the house. Okay, so this is another way to check the consistency of the models or the accuracy of the models. And this is another kind of example. So, I will take you to Excel sheet, and then I will show you. So, this is actually the problem which we have taken is like this and we like to know how to fit the regression model in order to predict the housing price subject to square feet and the age of the house. So, what will you do? Go to the data analysis, and then you select the data analysis package, and then check the regressions. Okay. So, that means see the idea is here in the kind of predictive analytics, you should know the kind of techniques, the kind of procedures, and then you can use any softwares. There is no hard and fast rules. So, you can use Excel spreadsheet, you can use SPSS, you can use EBUs, you can use R software, you can use SAS, you can use Tata. So, there are so many softwares are there, even you can use MATLAB. So, but the thing is that so we need to get the estimated equations in this particular case y with respect to x 1 and x 2. Since we know the model, so we have to just connect, and then the software will by default will give you the result, because when we have actually more number of data and the problem is very complicated. So, getting the results manually is very difficult. So, that is why we need actually the kind of software through which you will get the results. Once you get the results, then you will go for the kind of interpretation, and then we will go for the predictions, and then we will go for some kind of management decision. So, now corresponding to this problem, so so what will you do? So, first you give the input range. So, in this case you put actually input range here. Okay. So, then this is actually a y, and then you put actually a x 1s. So, this is same way we have to find out, then just put OK. This is same way you are getting the results. So, this is very easy actually. So, again you add one after another variable. So, then it will give you the output of output of the full models, and this is how the kind of f statistic, and then the R square, adjusted R square, and the number of observation countings, and the ESS, RSS, TSS, and the intercepts, the coefficients of all these parameters. So, that means actually, so we can also have the kind of lower bound, upper bound. So, that means software will give you all kinds of results. So, it will help you to go for the kind of prediction, but only thing that only requirement is that you have to know the technique, understand the technique, then point out the right dependent variable, point out the right independent variables, fix the kind of structure, check the data, then you will go for the kind of processing. So, once everything is okay, so just you give the command to the software, and software will give you just within few minutes it will give you the results. And once you get the results, with the help of the results you will get the kind of prediction structure, and you will do the predictions, and then you can go for the kind of management decision. So, this is how the kind of structure which you can have the process. And so, similarly, there is another kind of data. So, this is again cargo data, and then it is reflected by length of the roads and number of commercial vehicles. So, we are assuming that the cargo's reflections is reflected by length of roads and number of commercial vehicles. So, we are expecting that there will be a positive relationship between the freight cargo and the length of roads, and then the number of commercial vehicles, right. So, this is actually cross sectional data, because the reflection is country wise information, and again we have to check whether the variables are statistically significant to predict the cargo or the requirement. Okay. So, this is the same way, again it is with respect to dependent variable, and that too with respect to two independent variables x 1 and x 2, and again after simplifications the Excel output will give you the typical structures. And again, so once you go to the Excel output will give you the, so these are all actually intercept, and this is the x 1 indications, and so this is actually intercept, and this is x 1 indications, and this is x 2 indications. So, that means technically our model will be y equal to beta 0 sorry b 0 b 1 x 1s plus b 2 x 2. Now, the b 0 is this much, b 1 is this much, and b 2 is this much. So, accordingly you have to just fit the kind of model, and then you go for the kind of predictions. So, now before you go for predictions, so two minimum check you are supposed to do, whether it is a bivariate or a trivariate. Means this is the problem we are dealing with a trivariate, where we have a two independent variables and one dependent variable. And even if you for multivariate structure, so the rule is almost all same. So, the first requirement or first check before the prediction subject to the regression outputs. So, that you have to see whether actually the variables are statistically significant or not, and then the overall fitness of the model should be also statistically reliable and also statistically significant. That is actually judged through R square, adjusted R square, and the F statistics. So, technically you will go for the right predictions and the kind of right management decisions provided all the parameters will be statistically significant, and R square will be high, adjusted R square will be high, and f will be also statistically significant. So, if all these are in the right track, then obviously there will be perfect predictions, and then the management decision will be very perfect. But in reality, you will find when you will be dealing with this kind of problem with respect to a particular sample. So, you may not get the results as per the particular expectation or the particular requirement. So, now if you are getting the results as per the expectation, then there is no more complexity in the prediction process. So, that means the predictive analytics rule is minimal there, but when you will find some kind of complexity, for instance, if all the variables are not statistically significant or few variables are statistically significant, then R square is not actually coming in to a right right kind of percentage. For instance, it is coming close to 0.01 or 0.02 like this. So, in this kind of situations, so the signal is that the prediction cannot be actually a perfect one. So, that means the accuracy of prediction is a question mark. So, what we are supposed to do that so we have to re-estimate the process, that means the signal means the wrong signal may be with respect to functional form or with respect to the kind of sample size or the identification of variables. So, there may be many other issues. Once you get the first hand output for this particular problem for the prediction and the kind of management decision, so it will give you the kind of snapshot, or then you will try to find out the a right choice and the right combination, and then once you fix the right choice and right combination, that will be good enough to predict and then to go for the kind of management decision. But it is easy to say or easy to fix up, but in reality, so with the kind of dynamic world, the dynamics of business, you will find lots of complexity. Some variable will be significant, others will not, and variables are significant, R square is not supporting, while R square is supporting, variables are not supporting. So, there are lots of issues are there. So, now if your theory is very good enough and the logic is very good enough, and the kind of foundation or the linkage or the association is actually very perfect, then obviously, so the output or regression output should support, but any kind of fault or any kind of issue will minimize the particular process, and in that case this will again challenge for the predictive analytics to find out the issues and then correct the particular procedures, and you bring the kind of right estimated model through which you can do the prediction and go for the kind of perfect management decisions. So, what are the issues and how you can deal with all these issues, we will discuss in the next lecture. So, we will stop here, and thank you very much. Have a nice day.